Welcome to Alpha Beta Tutorials. In this video, we are going to perform a practical under electricity. This is Wassce 2019 Physics Practical. Without wasting time, let's go straight to the question. The introductory part of the question says you are provided with a battery. So this is a cell, this is the positive terminal of the cell, and this is the negative terminal. And two or more cells forms a battery. A key. These are the terminals for connection, and this is for closing and opening the circuit. A voltmeter. This is a voltmeter V for measuring EMF. A standard resistor, 2 ohms. A resistance box. This part measures up to 10 ohms. This dial also measures up to 100 ohms. This measures 1000, 10,000, 100,000, and so on. And some connecting wires. The I part of the question says measure and record the EMF E of the battery provided. So these are cell holder for holding the cell. You connect the positive terminal to the positive terminal of the cell holder, and then there's another one, positive terminal to the positive terminal, and then we join the positive terminal of the cell holder to the negative terminal to form a series connection and connect the negative terminal of the cell holder to the negative terminal of the voltmeter, and then the positive terminal to the positive terminal of the voltmeter to record the EMF. The EMF of the battery is 3.04 volts. At this part of the question, we are to set up the circuit as shown in this diagram. This represents the battery, this represents the key, and the line represents connecting wires. This is the resistor, and this represents the resistance box. And then the voltmeter is in parallel connection to the resistor of 2 ohms. So we join them with connecting wires. So we start from the negative terminal of the battery and then to the key. And from the other end of the key to the resistor 2 ohms. And then from the other end of the resistor to the resistance box. And then from the other end of the resistance box to the positive terminal of the battery. And we are to connect the voltmeter in parallel with this resistor. So we join here and here with connecting wires. Like this. At this part, we are to set the resistance in the resistance box to 2 ohms. Close the key read and record the potential difference V on the voltmeter. So our V is 1.14 volts. And we are to repeat the procedure for 5 other values and evaluate 1 over V. So we set the resistance to 5 ohms and we have 0.71 volts. And we set it to 10 ohms and we have 0.45 volts. Now we set this dial to 2 ohms and this to 10. 1 represents 10 here and this is 2. So a total of 12 ohms and we have 0.39 volts. So we change this to 5 ohms and this is at 10 ohms. So we have a total of 15 ohms and we have 0.33 volts. So we change this to 10 ohms, a total of 20 ohms and we have 0.25. So we evaluate V inverse, that is the same as 1 over V. So 1 divided by 1.14 is 0.88. 1 divided by 0.71 is 1.41. And 1 over 0.45 is 2.22. 1 over 0.39 is 2.56. 1 divided by 0.33 is 3.03. And here we have 4.00. At this part of the question, we are to plot a graph with R on the vertical axis and V inverse on the horizontal axis, starting both axes from the origin. Looking at the V inverse values, we have to convert them to standard form to be able to plot them easily. But the R values are okay. So with this value, we move the point 1, 2, which is times 10 exponent negative 2. So 0.88 becomes 88 times 10 exponent negative 2. We move the point twice here to 1, 2, and we have 141 times 10 exponent negative 2. Here 222 times 10 exponent negative 2, 256, 303, and 400 times 10 exponent negative 2. So we plot these values on our graph sheet. Let's draw the axis. So we are going to plot a graph of R on the vertical axis and V inverse on the horizontal axis. So we choose a scale for R. Looking at the values of R, a scale of 2 centimeters to 5 on the R axis will be okay. So we start from 0 over here, 5, 10, 15, 20, 25, 30, and here -5, -10, -15. And we choose another scale for V inverse. Looking at the values, the minimum value is 88 and the maximum value is 400. So a scale of 2 centimeters to 50 times 10 exponent -2 per volt will be okay for the V inverse axis. So we have 50 here, 100, 150, 200, 250, 300, 350, 400, and then 450. So we have 5 here. 5 divided by 10 is 0.5. So 2 boxes is 1. So we are going to plot 2 against 88. And with this axis too, we have 50 divided by 10. So one small box is 5. So our 2 will be 1, 2 means 1, 3, 4. That will be our 2. And then 88, we have 50. 2 boxes is 60. 2 boxes is 70. Another 2 boxes will be 80. And then one box will be 85. And now approximately our point will be somewhere here. We have 2 here and then 88. The next one, we have 5 and 141. This is 100. When we move 2 boxes, we have 110, another 2, 120, another 2, 130, 140. So approximately the point will be somewhere around this place. And the other one, we have 10 and 222. So this is 200. 2 boxes is 210. Another 2 boxes is 220. So 222 and 10 will be somewhere around this place. And then 256. This is 250. One box is 255. So approximately we have the point here, which is 256, and then 12. We have 303, and then 15 will be somewhere around here, and then 420 is here. So we draw our line of best fit, which should pass through as many points as possible. So this is our graph. At this part of the question, we have to determine the slope S of the graph and the intercept C on the vertical axis. So the slope is change in R over change in V inverse. So let's draw a vertical line and a horizontal line, label here A, B, and C. So the slope is the same as change in BC over change in AB. So for change in BC, let's draw these lines. So we have, remember, 2 boxes is 1 over here. So we have 15, 2 boxes, 16, 17, and 18 minus 5. And the unit for this axis is ohms. And for the change in AB, let's draw these lines here. And we have 350 minus, remember for this axis, one box is 5. So we have 100 here, 110, 120, 130, and 140. So we have 350 minus 140. Remember, we converted these values to standard form. So times 10 exponent negative 2, and the unit is per volts. And so 18 minus 5 is 13. And then 350 minus 140 times 10 exponent negative 2 will also give us 2.1 per volt. And so we divide these values, 13 over 2.1, which is 6.19. We have our ohm here. And when we reciprocate per volt, we get volts. And for the intercept on the vertical axis, our line of best fit cuts the vertical axis here. And remember, on this axis, 2 small boxes represents 1. So we have 1, 2, and 3. So our intercept is -3. At this part, we have to calculate alpha and beta from these equations. So let's pick the first one. S is equal to R naught alpha. So we divide through by R naught, and then alpha is S over R naught. And remember, our slope S is 6.19 ohm volts, and our R naught from the beginning is 2 ohms. So ohms will cancel ohms, and we have 6.19 divided by 2, giving us 3.095 volts. And let's pick this equation to C is equal to negative R naught plus beta. So let's expand the bracket with the negative sign. So we have negative R naught minus beta. And let's bring beta to this side of the equation. The sign will change to positive. And then we have our negative R naught, and bring C here to subtract. And so our beta is going to be, now R naught is 2 ohms, so we have -2 minus, and our C is -3. So beta is equal to -2 minus -3 is the same as -2 plus 3, and so we have 1. R naught and C are all in ohms.